Okay, so I will begin giving the demo. So this demo is to provide an automation of a process that is coming from a traditional workload, coming from a virtual machine that you can see here. Is a virtual machine executing WordPress. You know that WordPress is one of the content management engines, very popular in the world. Okay, and this is based with technologies like a PHP engines, and it has a MySQL database. Okay, in this traditional architecture, you can see that the preparation of the resources is very, let's say, not very easy. So this is in a weekly basis. And finally, the business iteration. So it's like showing the benefits to the clients. It can be in a monthly basis because it's very slow to be iterating over a virtual machines or premises architecture. Okay, so I will be switching to a cloud native workload that is based on containers in our CCE. So what I'm using here is a CCE, our Kubernetes software registry, in order to host the images of the WordPress and MySQL overall. And finally, with auto-scaling capabilities. So you will see here that we are providing Elastic Load Balancer, an Elastic IP. This is executing WordPress, PHP, engines, and MySQL capabilities. Okay, as you will see, this is providing running these workloads in containers. This is going to have the resources preparation is in hours, but basically we will do it in minutes because it's pre-prepared. Okay, and finally, the business iterations is in a weekly basis because this is automated. So all those capabilities are going to be very, um, very fast. Okay, so what is the methodology that we need to follow? Okay, I will begin from the step 3. Okay, just for you to know. But everything begins with the number 1. Okay, so it's we need to get the inventory to have like an assessment on how many virtual machines or on-premise uh, physical machines the client has. Okay, like in this part. After that inventory, we need to begin classifying those workloads. Okay, so all these virtual machines should be executing several applications. Okay, so we need to analyze those applications in order to determine the layers. Basically, the layers can be divided in a workload layer, middleware layer, libraries layer, and kernel layer. Okay, so this is an example. Like in layer 1, the client can be running Windows, Ubuntu, several operating systems. In the layer 2, can have like workloads executing over Java, Python, binaries, shells, Go, etc., several languages. Okay. In layer 3, we can see that what is the middleware that the client is using, like Tomcat, Maven, MariaDB, Wildfly. This is there's a typo in here. It's Wildfly. So there are several middlewares that the client can have. And finally, what is the application at the top layer? Okay, like they are using a web application, web workloads, mobile applications, artificial intelligence, monitoring applications, etc. Okay, so we need to classify that. And after that, we need to decide which is the best application with all the layers that needs to be migrated using a containers strategy. Okay, so basically, in the containerization strategy, we need to provide a Docker file. The Docker file is the basic file that needs everything that is going to be automatically implemented. Okay, so we establish the workload images. For instance, the for all these layers, we can have everything in a workload image. And finally, we provision where could be in the software registry, the images, and in the Kubernetes, all the workloads. Okay, it could be in CCE, in CCI, in function graph, or even in our multi-cloud architecture that is UCS. Okay.